A particle having a charge of 5 microcoulomb and mass of 5 into 10 to the power minus 12 kg is projected with a speed of 1 kilometer per second in a magnetic field of magnitude this. The angle between the magnetic field and the velocity is sine inverse of 0.9. Fine. Now first of all make the diagram. Let's say this is the direction of my magnetic field. Velocity is like this. And this angle is theta, and it is given that sine of theta is equals to 0.90. Show that the part of the particle will be a helix. Fine. And find the diameter of the helix and its pitch. Now first of all, I'll take the component of the velocity, that will be v sine of theta, and this will be v cos of theta, and this will be v sine of theta. Right. Now I will assume that there are two different velocities in two different directions. Fine. I have to calculate the diameter of the helix first of all. Now first of all I'll show you why it is a helix. Fine. V sine theta, it is perpendicular to magnetic field, so it will start rotating in a circle. Right. It will rotate in a circle like this, like this, like this, right, continuously. But now it is having a velocity v sine theta in this direction. So it will rotate continuously in a circle. Together with that, it will move ahead with a velocity v sine theta. And such a kind of motion is known as a helix. Right? Now I have to calculate the diameter of the helix. Now diameter is given by 2 times of r, and radius is given by mv by qb. Fine. Now velocity over here will be v sine of theta, because v cos theta is in the direction of magnetic field, so it will not contribute anything to the radius of the motion. So it will be 2 times of m v sine of theta by qb. Right. So just substitute all the values. Mass is known to you, velocity is known to you, sine theta is given 0.9, charge is 5 microcoulomb, and the magnetic field is 5 millitesla. So the diameter comes out to be 36 into 10 to the power minus 2 meters, or that is equals to 36 centimeter. Fine. Now in second part I have to calculate the pitch of the helix. Now pitch of the helix is basically the distance it covered when the particle is at the same point. Let's say this point and this point is in the same phase, so the distance between both of them is the pitch. Right. Now I can clearly apply v cos theta, that is the velocity in the x direction. Let's say this is my x direction, so velocity in x direction is equal to distance upon time. Fine. So distance is equal to pitch, that what I have to calculate, and the time taken by the particle to complete one whole circle so that it can come in the same phase is equal to time period. Fine. So I can write 2 pi m by qb, that is what time period is, into v cos of theta is equal to the pitch. Fine. Just substitute all the values. I have 3.14, mass is 5 into 10 to the power 12, charge 5 microcoulomb, magnetic field is 0.5 into 10 to the power minus 3 millitesla, velocity is given as 10 to the power 3, and cos of theta. Fine. Sine theta is known to me. Let's say this is my theta. Sine theta is perpendicular to that of hypotenuse, so perpendicular is 0.9, hypotenuse is 1. I can calculate this by the Pythagoras theorem, 1 minus 0.9 whole square. So cos theta comes out to be base upon hypotenuse, that is 1 minus 0.9 whole square by hypotenuse, that is equal to pitch. Solve this equation, you get the value of pitch as 54 centimeter. That is the answer.